In this video, we will look at work done by a force, kinetic energy, gravitational potential energy, and the work energy theorem. Now let's look at the formula for work done by a constant force. In words, work done equals force times distance times the cosine of the angle between them. In symbols, work equals F times d times cosine theta. Next, let's look at the formula for kinetic energy. In words, kinetic energy equals 1/2 times mass times velocity squared. In symbols, kinetic energy equals 1/2 times m times v squared. Next, let's look at the formula for gravitational potential energy. In words, gravitational potential energy equals mass times gravity times height. In symbols, gravitational potential energy equals m times g times h. Now let's state the work energy theorem. The work energy theorem says the work done by the resultant force equals the change in kinetic energy. Let's now work through an example together. A car of mass 800 kilograms accelerates from 10 meters per second to 25 meters per second. Step 1. Find the initial kinetic energy. Initial kinetic energy equals 1/2 times 800 times 10 squared. This gives an initial kinetic energy of 40,000 joules. Step 2. Find the final kinetic energy. Final kinetic energy equals 1/2 times 800 times 25 squared. This gives a final kinetic energy of 250,000 joules. Step 3. Subtract to find the work done. Work done equals final kinetic energy minus initial kinetic energy. That is 250,000 joules minus 40,000 joules. This gives a work done of 210,000 joules. For the check step, we confirm the answer is positive since the car sped up, and the final kinetic energy is greater than the initial kinetic energy, which matches our result.